this is where you come to do winter testing. This is the place that have all the grades, all the conditions to get this truck tested. Every single truck OEM and Tier 1 come to this place to make sure that they get the cold weather, snow packing, so that we can do the main testing that we need and get the facilities that we need. Well, thanks everyone. Let's get the plan for the day. The idea is to start the truck inside today, then we'll drive out. Ideally, we'll just break in the truck. Let's do some no load first, just bobtail. So as we've built 7 trucks for the alpha phase, 2 of those we've already delivered to our customers in LA. This is the instrumented fuel cell alpha truck where we have hundreds of sensors and instrumentation to capture data and then do optimization. So that would be the main goal for today. Make sure the truck starts on warm start, goes out bobtail, comes back, then goes out again fully loaded, figure out the battery temperature logic, and then the fuel cell cool down so that we're then ready for tomorrow trying the cold start. Anything else? All right, let's get this one done, guys. Have a good day. Being able to do power management and energy management to ensure that the vehicle will perform in all the different weather conditions and environmental conditions. By the time these trucks go to production, there will be a lot of fine-tuning and different areas that we've already gone through.
This is a 200 kilowatt fuel cell system. The scale's just of a different magnitude. We are developing a fuel cell for a Class 8 truck, which is going to see over 1 million miles. So in comparison, that's about 5 to 10 times of what a typical passenger car is going to go through. So that's really what makes it unique and just so different.
What's coming out of the tailpipe of this thing?
No, that's just exhaust, but it's free of all the usual emissions you see with a truck. So this is just steam, as pure and good as it can get. That's the fuel cell running, and we're making power. The exhaust is only at about 80 degrees Celsius in comparison to a typical IC engine, right, which is putting out exhaust at almost 600 degrees Celsius, right? This is a lot lower. I'm totally fine putting my face right next to it.
This is FC5 and FC5 support engineering, area 51. So I'm gonna go down to the end and then come back, and then I'm gonna do some figure 8s just to warm up. In this area over here, what we do is we're going to test ABS. We're going to make sure that ABS works. This is probably about a football field and a half full of ice. It's going to slide, but this is flat worst case scenario. I'm really curious to see what fuel cell does in the first iteration. Ready? It's going to be slow steers, and get ready to giggle. All right, here we go. It's really good. Yeah, it is really good. All right, that was pretty good. I'm gonna do one more, and then we're gonna break for lunch. So, Roddy, just to let you know, the ABS on fuel cell will not let me spin this vehicle around. It is very good.
Thanks. I want to make sure the engineers hear about it.
All right, here I go.
Break.
Woo! Woo-hoo-hoo!
What are you thinking, my friend?
ABS is really great on this vehicle. Braking on the ice in this vehicle is phenomenal. And that's the first iteration, so it's very good.
Great day so far. The truck did great. The truck had fun on the snow, on the ice, but truck is ready for get some load on. So we're gonna put the trailer now. The plan is to get 80,000 pounds and go out again, do more snow, more ice, and come back and see how did we do.
Great day. Good job on traction control and yaw sensing, and tried to get the vehicle out of character, would not get out of character.
Okay.
Phenomenal.
Great.
I am
Sweet.
stoked.
It's a cold and chilly morning, 10 degrees Fahrenheit. We put the truck outside our heated tent and let it cold soak overnight, where the temperatures drop down to about minus 15 degrees Celsius, give or take. We knew that some of the sensors freezing up because the fuel cells make water. As a countermeasure, we put some heating blankets around the fuel cell. As part of what we've learned already, we're already making changes to our beta design. If we had all this perfected, we would be in production today. So we're not yet there, but we are learning, and it's a continuous process.
The temperatures on the fuel cell are not ideal right now, but we're gonna get out of the way today, the BEV mode cold start.
Okay.
And we have enough SOC that we could take it out for a spin, no problem, so
Okay.
that should be okay.
So right now we're in the northern part of the Upper Peninsula of Michigan.
Can you report SOC again? Richard is trying to get the truck to fight with the lane change and get the truck to come back on lane and get it stable. And so the stability control system is jumping in and keeping the truck stable, and so far so good. How is it going?
Pretty good. We were able to get up to, 65
wow.
kph for the lane change maneuvers. So with respect to the control brake system, I'm completely ecstatic. That ability to make cars safer than the drivers can do by themselves and have them going, wow, this is great.
So we're ready to wrap it up. We've gathered a lot of data that we needed for the beta phase and for additional development. Our truck is ready to go for a final evaluation and a final spin.
What I'm gonna do is a series of lane changes. 3, 2, 1, to left, back, to right. Good. Very good.
There is 1,000+ people behind that truck that made it come to the place where it is right now. All our suppliers, our plant, our engineers, our supply chain team, Everyone that's behind this truck has made it possible to be here today. This is a transition that is not easy. Definitely a one-in-a-lifetime opportunity to be an engineering in this time of transportation. We are really pushing the envelope and changing completely the trucking industry into what the future will look like now.